7.1 is the trigonometric identities. So here 7.1 trigonometric identities. Yes. So trigonometric identities, so we have to know the identities for the trigonometric. First of all is, so here we have the fundamental identities. Fundamental identities. The fundamental trigonometric identities is here, first part in this section. So here we have different kind of identities. The first one is the reciprocal identity. Reciprocal identities. So first one of the reciprocal identities is the cosecant, number one. Cosecant of the angle x is the same as 1 over cosine x, 1 over sine. 1 over sine of x. Number two is the secant of x is the same as 1 over cosine. Third one, cotan of x is the same as 1 over tan of x, or I can say is the reciprocal for tan is the cosine of x over sine of x. Number four, the tan of x is the sine over cosine of x. So all of these 1, 2, 3, 4 is called the reciprocal identity. We have also the Pythagorean identity. The Pythagorean identities is here. So the Pythagorean identities is defined as number one, we have to know the sine square of x plus cosine square of x equal 1. Number two, the tan square of x. So we're dividing this by cosine. By dividing this by cosine, sine square over cosine is tan square. Cosine square of x over cosine square is equal 1. Equal 1 over cosine square is secant square. Number three, if we divide this one by
will be 1
sine, it will
1
be
plus
1
locus tangent square equals
cotangent square.
cosecant square.
Okay, that is cosecant square. Yes, exactly. This is the Pythagorean identity. The last identity is the even odd identities. The even odd identities is defined as here. So the first one is So we have to know the sine function is odd function. So the sine of minus x is the same as minus sine of x. Number two, the cosine function is even function. So the cosine of x is equal as cosine of minus x. And third one, to know that tan is tan function is an odd function, so tan of minus x is the same as minus tan of x. So this is the only identity here, tan of minus x. This is the identity we have to use it during this section for proving and for simplifying. Okay. Now, first things in this section is how to simplify trigonometric expression. So here simplifying. Trigonometric function. I mean expression. This means if I have expression, by using this identity, I can change this expression to another expression are equal to the first one. Okay, I mean for here simplifying trigonometric expression, I can write my expression in different way. So let me give you example for that. The question is simplify the expression below. Simplify the expression cosine of t plus tan of t times this t is the angle here, tan of t times the sine of t. So I have my expression. This is my expression. I need to change it, or I can write it in different way by using what? This identities. The reciprocal, the Pythagorean, the even odd identity. So let me do this one step by step. So I have cosine of t. Cosine of t is in the simple way. Here the tan of t, I can change it by using the reciprocal identity. So what is tan of t? Number 4. Look, number 4 is equal sine over cosine. So this is equal plus sine of t over cosine of t times sine of t. What is that equal? So this, I can simplify it more. So I get cosine of t plus sine times sine is sine square of t over cosine of t. Now I have to make between this term and this term, I can make the common denominator. So how can I make the common denominator?
Multiply by cosine.
Yes.
Bottom and
this
top.
exactly. So this is over 1 actually. So I have to multiply this by cosine of t and multiply here by cosine of t. So when I multiply by in the numerator by cosine and the denominator by cosine, like I multiply by 1. So I get now cosine times cosine is cosine square of t over cosine of t plus sine square of t plus over cosine of t. So now the denominator are equal, so I can make it common denominator, cosine of t. Now cosine square of t plus sine of square t. What is that equal? Cosine square plus sine square. What is the cosine square plus sine square? Exactly, it's 1. Look, Pythagorean identity. Sine square plus cosine square is 1. So the answer is 1 over what? Cosine of t. So look, all this expression here is equal 1 over cosine of t. So I can change the expression to a different way, like by simplifying and using the identity before. Is it clear? And what is 1 over cosine equal?
Secant.
Secant. So everything here is secant. So this here equals secant, actually. Okay? So this is the simplifying of the trigonometric expression. Okay, I'm going to give you another example. Any question for this one? Before we move. So the simplify is meaning use the identity. Okay. Example 2. So the question is simplify sine theta over cosine theta plus cosine theta over 1 plus sine theta. How can I start for this one? Any idea how to simplify?
Sine over cosine is equal to tangent, right?
Where?
There.
This tangent theta plus cosine of theta over 1 plus sine of theta. Here I get Martin, he said, what about if we do the common denominator? Yes, this is true too. Here is William. The question is asking for simplifying. So this is when you convert the sine over cosine to tan is not simplifying.
See.
To simplify means like make the answer by equal sine or cosine.
Oh,
So
okay.
simplifying like changing everything to sine and cosine. This is what I mean of simplify. But here we not make it a simplify by make it tan. So this is a good idea, William. Thanks. So the sine over cosine here, the best way is to make the common denominator. How we can find the common denominator? By cross multiply. This by this, and this by this. So sine times 1 sine is equal sine times 1 plus sine. I mean sine of theta. Sine of theta times 1 plus sine of theta plus cosine square, because cosine times cosine is cosine square, over cosine times this. cosine theta times 1 plus sine theta. Distribute the sign inside the parentheses. What I get?
Sine plus sine squared
Sine plus sine squared
plus
plus
cosine
cosine
squared
over what?
over cosine
Theta.
plus.
I'm not going to distribute the second one. I tell you why. I'm not going to distribute the cosine here because look up. Sine squared plus cosine squared is
1.
1. So the value here now equals sine theta plus 1 over cosine theta times 1 plus sine theta. So again, cancel this one by this one, right? The sine theta plus 1 with this parentheses. Okay? So now I get 1 over cosine theta. What is 1 over cosine theta? Secant, yes, secant theta. So look, all this fraction is equal secant theta. So the simplifying for these things is secant theta. Any question? Okay, so all this fraction is, this expression is a secant. So now this is what we have to know about simplifying the expression. Now, proving the trigonometric identity. Any question for this thing? So proving trigonometric identities. Okay, there is a step to prove. Is the step how to prove the trigonometric identities. So first step is to start with one side. Then use the no identities. Now we have to convert everything to sine and cosine to simplify. So I'm going to give you an example. And the example is prove this identity. So for simplifying is different about a proof. Simplifying, just we try to convert everything to sine and cosine, and in the end we find an expression. This expression are equivalent to the expression I started for. But for the proof, I have to hold one side, try to solve it this side until I arrive to the other side. So example here. proof the equation the expression cosine theta, here cosine secant theta minus cosine theta equals sine square theta. So again, the way for the proof, just hold one side, this side or this side, whatever you want. Then you try to simplify this side until you arrive to the point to the second side. Or there is another way. You hold one side, you arrive at a point, you hold the second side, try to simplify to arrive at another point. This point and this point must be equal. Okay? Now, how can I start which side I want to prove? You're looking for the both side. We're starting for the complicated side in general. Like in this one, I don't start from this side because sine square of theta, I don't have enough information to try and to simplify to arrive to this side. Okay? So in the best way, starting from the complicated side, it's look like this side is more complicated. Then I simplify it until I arrive in the end equal sine square of theta. And when I arrive this point, this means I prove this expression. Okay? Okay, another way, another time, another more one time. Again, there's two ways for proof. The first way is to hold one side, this, for example, try to simplify it. In the end of the simplify, you arrive this point. When you arrive to this point, this means I prove this expression. Or I start from this side, I simplify it, then I arrive in the end by this expression. This means I prove the expression. Or there is another way, just hold one side, you arrive at point, you stuck at point, you simplify the other side, you stuck at this point and this point are equal. So this is we prove the expression. Okay, I'm going to do this one. Which side is more complicated to start for? If we look into this expression, it's look like this side is better to start with. So I'm going to hold this side. I try to simplify it until I arrive to this side, sine square of theta. So cosine of theta times secant of theta minus cosine of theta. How can I simplify this one? So here I can set the left hand side. How can I simplify this one? Cosine of theta, secant of theta minus cosine of theta. So I can do this for the secant of theta.
Secant, yeah, secant's 1 over cosine, right?
Yes. So exactly. So here I get cosine of theta of 1 over cosine of theta minus cosine of theta. Now simplify this in parentheses or make the common denominator. So the common denominator here actually is over 1. This is over 1 here. So we do cross multiply. The one by 1 and this one by this and the one by this. I get now cosine of theta is equal 1 minus cosine. Let me check. So 1 times 1 is 1 minus cosine times cosine is cosine square, theta square, over this times 1 is cosine theta. Yeah, this is true. So now we multiply this by the parentheses. I get this with this is cancelled, cancel each other. Now I get this equal 1 minus cosine square of theta. What is 1 minus cosine of theta, square of theta?
Sine square.
Sine square of theta. How I know? By this here. Sine square plus cosine square equal 1. So 1 minus cosine square is equal sine. So again, 1. I'm not going to do it here. 1 minus this things is equal this things, sine square. And this is what I have here. So 1 minus cosine square of theta is equal sine square of theta. And this is equal to the right hand side. This is equal to the right hand side. This means I prove this expression. Any question? Any question? Is it clear how to do it? Okay, so another example. So I start from left hand side, I arrive to the right hand side. This is the main idea. Here, example. Two tan of x secant x equal 1 minus 1 over 1 minus sine of theta, sine x, I mean, minus 1 over 1 plus sine. Okay. Which side I would like, I should start? I start for like more complicated side. Would you like to use in the right or the right or the left? Which is more complicated?
So, right?
If I start from the right, it's better because it has fractions, and the fraction is more harder and more complicated from the left side. So let me start from the right hand side. This is equal here 1 over 1 minus sine x minus 1 over plus sine of x. So the step now we have to make the denominator are equal. By what? By doing the cross multiply. So here the minus, I can move it to up. Can make it like this. Here plus, make it the minus here. So this times this one times this one, and this times this. So now I get 1 minus sine times this one is minus 1 times 1 minus sine x. Here 1 times this one is plus 1 plus sine of x. And we multiply the denominator is 1 minus sine times 1 plus sine. It's the complete the square, complete. So 1 times So 1 minus sine square times 1 plus sine square is equal 1 minus sine x square. Why? Because this is equal like this, 1 minus sine x times 1 plus sine of x, and this is equal 1 times 1 is 1, 1 times sine is sine plus sine, minus times 1 is minus sine, and minus times minus is minus, sine times sine is sine square. This and this cancel each other, so I get 1 plus 1 minus sine square of x. And this is here. So what is 1 minus sine square of x? Cosine square, exactly. So I'm going to erase all of this. So this 1 minus sine square is cosine square. Now here I can simplify it more, so this is equal. The minus I distributed inside the parentheses, and I simplify at the same time, so I get minus 1 plus sine x plus 1 plus sine of x over here 1 minus sine square is cosine square of x. How? Same things here. Sine square plus cosine square equal 1. So now here I can simplify because I have minus 1 and 1. This cancel with this. Sine plus sine is equal to sine of x over cosine square of x. So this is actually equal to times sine of x over cosine of x times 1 over cosine of x. This cosine square is equal cosine times cosine by factoring. So I factor. Now, what is sine over cosine? 10, right? Sine over cosine is 10. And what is 1 over cosine?
Secant.
Secant. So I get 2 tan secant. Same like the left hand side. 2 tan secant equal left hand side. Finished, done. Is it clear how to prove? Anyone has any question for how to prove the identity? Okay. Another one. But if I start from this side, it's gonna be like hard to arrive to the other side. Like if I start from 2 tan secant, will be hard to arrive to the other side. I can arrive, I can, but it's hard. What is the LHS? Is the left hand side. Angel, this is the left hand side. RHS, the right hand side. RHS is the right hand side, I mean like this side. Right hand side, this side. This side, left hand side, this side. Another example. Proof. 1 plus cosine of theta over cosine of theta equal tan square of theta over secant theta minus 1. How can I prove this one? Any idea?
Cross multiply?
No, okay, a lot of students, they get mistaken these things. For proof, I can't do cross multiply. I have to start from one side, simplify it until I arrive to the second side. I can't do cross multiply, and this is wrong. It's not this the proof. The proof means starting from one side, like left hand side or right hand side, simplify, arrive to the second side. Which side would you like to use? I think this is more complicated, right? The right hand side. Here, so you can use tan square equal plus 1, tan square plus 1 equals secant. I can't do cross multiply. How you get tan square plus 1 equals secant square? Let's start from the second side, okay? It's left hand side. So tan square of theta over secant theta minus 1. Okay, what is the tan of theta? Tan square.
It's sine squared over cosine squared, right?
It is sine. You can use this one, right? Here. The tan square of theta equals secant square minus 1, right?
Hmm.
Secant square minus 1. But I don't know if it's gonna use it. It's okay. So it's equals secant square minus 1 over secant square secant theta minus 1. This is equal secant theta minus 1 times secant theta plus 1 over secant theta minus 1. So I can cancel this by this one. And I get what? Secant theta plus 1. What is the secant theta?
1 over cosine?
1 over cosine of theta plus 1. Now cross multiply. This is actually over 1.
So it's cosine over cosine.
So I get cosine of theta plus 1 over cosine of theta. And this is equal to this side, equal to the right hand side. Perfect. Is it clear? Okay. So this is the proof. This is the way for proving. Hold one side, work in the one side until you arrive to the second side. Okay, by this proof, we finish this section. I'm going to give you exercise. Proof. Cosine u over 1 minus sine of u equal secant of u plus tan of u. So you have to hold one side, try to simplify it until you arrive to the other side. Any question? Okay, so by this example, we finish this section. So let's go to the new section at 7.2. Is it clear, this section? Do you have everything is fine here? Okay, so 7.2 is adding and subtracting formulas. Here, 7.2. So this section is simple. Just you have to use the formulas for adding and subtracting any triangle. So first of all, you have to know for the sum sine. If I have s and t, both of them are angle. So sine of s plus t is equal sine of s cosine of t plus sine cosine cosine 1 cosine of s sine of t. So sine cosine cosine sine. This is for the sine. Now for the sine of s minus t is equal sine of s cosine of t minus same cosine of s sine of t. This for the sine. Now for cosine. Cosine for s plus t is equal cosine of s cosine for t minus opposite sine for s and sine for t. Same things for cosine s and t difference minus. So this is equal cosine of s sine cosine of t plus sine of s sine of t. For the tan s minus t and tan small bigger. So tan s plus t. So this is equal tan of s plus tan of t over 1 minus tan of s tan of t. Same things for the minus, tan s minus t equal tan s minus tan of t over 1 plus tan s tan t. This is formulas, you have to memorize it. So Angeli said I'm lost. So you don't have to lose, just memorize this formulas. So sine s plus t, you have to memorize it like sine, cosine, cosine, sine, sine, cosine, cosine, sine. For the cosine, only cosine, cosine, sine, sine, cosine, cosine, sine, sine. But for the sine here, look, positive, keep positive, negative, keep negative. For positive, change it to negative, negative, change it to positive. Tan s plus t is equal tan s plus t, and the minus is in the down here. Here the minus up because the same, like the same sign, and here the positive. Okay, so you have to memorize these formulas. This is for adding and subtracting. Clear? Okay. Any question for these formulas? So I give you example. So example. So by using the addition and subtraction formulas, find each of the following. So number one, find the value for cosine of 75 degree. How can I find the cosine for 75 degree? By using, by using the addition and subtraction formula. This means like I have to write it as cosine of two angles. These angles, I know the cosine for them. I know what's the cosine and the sine for them by previous sections for the 75. So I can add or I can subtract. Which the best two angles I can use it for 75? Give me two angles. I know the cosine and the sine by using the special values. The sum of these two angles is 75, or the subtract of these two angles is 75.
125.
100
And 25
and
minus
25. This is true, but the cosine of 100, I have to use the calculator. I don't have to use the calculator. And also the same things for cosine 25. I have to use calculator. I need the angles using by theory because I know the cosine for theory and sine for theory. 45 and
Can we
60.
change it to radian?
If we change it, the radian will not be useful too.
You just
I
do 30
need
and 45.
3 plus 45, right? 3 plus 45, they give me what?
Yeah.
So I'm going to use this only angles because I know the sine and cosine for this angle. Because the theory is actually pi over 6. I know the sine and cosine for pi over 6. And 45 is actually pi over 4. And the 60 is pi over 3. So these things, by previous section, I know the sine and cosine for this angles. So the best things here to make it 75 is using theory plus 45, because theory plus 45 is 75. Now, using the formula for cosine and adding. Cosine the first angle plus the second angle is equal cosine the first one, cosine the second one, subtract the sine of the first one, the sine of the second angle. So this is equal cosine of theory, cosine of 45 minus sine of the theory, sine for the second one, sine for 45. If I want to change it to radian, would be the same, fine. But last time I think I gave you, okay, let me change it to radian. Maybe you are familiar in radian. So this is equal cosine for the theory is pi over 6, cosine pi over 4 minus sine of pi over 6 and sine of pi over 4. What is the cosine for pi over 6 from the table?
Root 3 over 2.
What is it?
Square root of 3 over 2.
Yes. What is the cosine for pi over 4?
Root 2 over 2.
Square root of 2 over 2, yes. Minus sine of pi over 6, 1/2, I think, right?
Mm.
1/2. And what is the sine of pi over 4?
Root 2, 2.
Yes. Angeli asked for this formulas, we will be using the angle from 0 to 90 only. No. What do you mean, like this formulas, cosine and sine? For cosine, I can find any angle between 0 and 2 pi. I mean from 0 to 360. For this formulas, we will be using the angle from 0 to 90 only. I can use bigger than, more than. Yes, exactly. For these things, it's better to use the theory 45, 60 and 90 degree. 0, 30, 45, 60. Because I know the sine and cosine for these angles. And 92. And any angle has the same reference for theory. The same reference for theory is 150, for example. 150 has the same reference for theory as we learn in chapter 5, I mean. Okay. So let me simplify these things here. So I get now square root of 3 times square root of 2 is square root of 6 over 4 minus square root of 2 over 4, and the answer is square root of 6 minus square root of 2 over 4. Any question for this? Is it clear?
Professor, can you go back one page? I missed one thing.
Yeah, sure.
Okay, thank you.
You're welcome. So now by using this formulas here, I can find like any cosine without using the calculator. Without using the calculator, I can right now find the cosine for 75 degree by using the formulas of before. Cosine 30 plus 45, 30 degree plus 45 degree. And the same idea like using the formulas cosine, cosine minus sine, sine. And I know the cosine for 30, I know the cosine for 45, sine for 30, and sine for 45 by using the table in the chapter 5. Okay, another example is here. Find the value for b. Find the cosine for pi over 12. How can I find the value for pi over 12? Pi over 6 plus pi over 3 plus pi over 3. Let me check. But I need, okay. Pi over 6 plus pi over 3 plus pi over 3. And they give me what? Pi over 6 plus 2 pi over 3. And this is equal 3 plus 12. 3 plus 12. 15 pi over 18. And this is not the same like pi over 12. No, this is not the same as pi over 12. So the best things here, I have to looking for angles such that the cosine of this give me a plus or minus any like any angle. I know what is the value for them. Like I know the value for example, the pi over 3. I know the value for pi over 6. I know the pi for pi over 4. I know for the pi over 2. I know for the 0, 2. So I need like angle. If I add or subtract, they give me pi over 12. So the best things here, I have to factor number 12. The factor for number 12 is 3 and 4 and 6. Okay, so I can set 4 by and also 1. Also here 1. These numbers are the factor for 12. So I can set 4 by minus pi. That's true. Oh, hold on. No, but 4 by minus 3 by over 12. Because 4 by minus 3 by is 1. 1 by over 12. Exactly. So now I can set 4 by, I can divide it by 12 like this, cosine 4 by over 12 minus 3 pi over 12. And this is actually equal cosine 4 pi over 12 is simplify, it's pi over 3 minus this simplify as pi over 4. The pi over 4, I know the value for sine and cosine for this value. I know the sine and cosine for pi over 3 too. So now it's good. This is work. 4 pi minus 3 pi over 12. This is actually work for this simplify. There is another way is there is like, if you're thinking more, you can find pi over 4 minus pi over 6 too. But I recommending this values because this values is more easy. Okay. So what's now the cosine for this value? Go back to the formulas. Cosine for s minus t is cosine cosine plus sine sine. So this is equal cosine cosine minus, become positive, sine, I write it here is better, cosine cosine plus sine sine. So cosine of pi over 3, cosine pi over 2 over 4, sine of pi over 3, and sine pi over 4. What is the cosine for pi over 3 from the table? What is the cosine for pi over 3? I need help. Anyone know what's the cosine of pi over 3? 1/2, yes. So it's 1/2. What is the cosine for pi over 4? It's easy, square root of 2 over 2. What is the sine of pi over 3? Square root of 3 over 2. Sure, right, Martin? And what is the sine of pi over 4? Square root of 2 over 2. Okay, now we have square root of 2 over 4 plus square root of 3 times square root of 2 is square root of 6 because we multiply inside the square root over 4. So now I get square root of 2 plus square root of 6 over 4. This is the value for cosine pi over 12. Any question? Anyone has a question? Is it clear?
Yeah, that makes sense.
Okay, so now another example. So the example is find the exact value of the expression. Find the exact value for the expression is sine of 20, sine 20, cosine 40, sine cosine, plus cosine of 40, cosine of 20, sine 40. What is this value equal? The question is, find the exact value for this expression. So look to this expression. Sine, cosine, cosine, sine. And we have positive adding. Go back to the formulas. Sine, cosine, cosine, sine. We have add. So this is equal sine of the first angle plus the second angle. The first angle, this is the second angle. So what is that equal here? What is that equal? So sine, cosine, cosine, sine is equal to which function? Which function? Yes, Martin. So this is equal to the sine from before. This is the first angle, 20. This is my second angle, 40. So this is equal sine of what? Of 60. And sine of 60, if I want to change it to the radian, like to simplify if you want. If you don't want to change it, it's fine. You can give me the answer right away. So this is equal sine of pi over 3. Because 180 divided by 3 is 60. What is sine pi over 3? From the table again. What is the sine of pi over 3? Do you know what is the sine of pi over 3? It is pi over 3 is square root of 3 over 2. This is the sine of 60. So the value here has like the sum of this two values, the sum of this expression is equal square root of 3 over 2. Okay. So now we can like also find the exact value for the sum and for the sum of the expression. Okay. Is now the last example in this section is improving. So now example, prove. What we have to prove that cosine of pi over 2 minus u equal what? Equal sine of u. So like I said before, to prove I have to hold one side, this side or this side, simplifying until I arrive the second side. Which side I should use? Left. So Martin, he said it's better to using left side. So left hand side. So I have cosine of pi over 2 minus u. Now, by using the formulas before, cosine and we have negative between of the angle, this one. Cosine the first angle minus the second angle is equal cosine cosine plus sine sine. So now I have cosine plus sine sine. first angle pi over 2. Second one u. Sine of first angle. Second angle. Now, what's the cosine of pi over 2? 0. Yes. From the table. Times what? Times cosine of u plus. What is the sine of pi over 2? Is 1. Yes. Times the sine of u. 0 times anything, 0. So the answer is 1 times anything is this thing, sine. So the answer is sine of u. Sine of u, it's the left hand, it's the same like the right hand side. Right hand side. So done. So this is the proof for this example. Any question? Any other questions? Okay, so now 7.3. And the other example in this section is not required for you. Just only example like this, how to find the cosine for angles. You have to find the two angles such that is known for us. Second thing is you have to know how to find the exact value, something like this. Third example, you have to prove simple something like this by using the formulas before. Cosine, angle minus angle, and using this just the formulas, and you arrive to the second side. And you have to memorize all these formulas. 1, 2, 3. Okay. Now the third section is double angle, half angle, and the product sum formulas. So now we have to go over the double angles. So here, double angle, half angle, and the product sum formulas. So double angle formulas. You have to know the double angle formulas. So here, the double angle formulas. Okay, so I give you the formulas here. So the formula for the sine, first of all, so first formula is for the sine. You have to know the sine of any double angle 2x is equal to sine of x, the half of the angle, cosine of x. This is for the first one. Second one is for the cosine. So you have to know the cosine of 2x is equal, it has three formulas. The first one is cosine square x minus sine square x, or this is the first one. And also I can say cosine of 2x has different formula, is 2 cosine of x 2 cosine square of x minus 1, and the last one is cosine of 2x is equal 1 minus sine, 1 minus 2 sine 2 sine square of x over what? Without over. Okay. This is for the cosine, this is for the sine, and the last one is for the tan. So you have to know the tan of the double angle 2x is equal the 2 tan x over 1 minus tan square x. Tan square x. How we would know which one to use and when? So it depends. Like if the question talk about sine double x, you have to use the first one. The cosine, it depends. Like cosine square, sine, or like if I need it just for cosine, I just use the cosine. If I need it only for sine, so I use it for sine. For the tan, it has one. So for the sine and the tan are easy because they have one formula. For this one, it depends on the questions. Okay, so example. So the question is example 1. If cosine of x is equal minus 2 over 3 and this x in the third quadrant, in quadrant 3, not 3 is 2, second quadrant. The question is find cosine 2x and sine of 2x. Any idea how to solve this? How can I start for the first one? Cosine 2x. So I have cosine is given and x in the second quadrant. So I have to graph, show by the graph. So the angle, it's in the second quadrant, something like that. Here's in the second quadrant. starting from this point up to this. This is my theta, my x. I don't have to use circle, don't need it. So my x, the angle is x in the second quadrant. In the second quadrant, the cosine is negative. The only function is positive is the sine. That's why the cosine is negative. Okay. How can I use the cosine to find the cosine of 2x? Use this formula. Which formula is better to use it? Is 1 or 2 or 3? So they give me only the cosine of x. So to find the cosine of 2x is the better to use this one, number 2. Why? Because in the question they give me only the cosine. So I can use this one to find the cosine of 2x. So the question is, now I can use the formula 2 cosine square of x minus 1. This one. Cosine of x is given. So this is equal 2 times minus 2 over 3 square minus 1. The answer is 2 times 4 over 9 minus 1. Now this is equal, 2 times 4 is 8 over 9 minus 1. And this is equal what?
-1/9.
Negative 1 over 9. So this is the answer for the first one, the cosine 2x. It's negative again because in the second quadrant the cosine is negative, the cosine of 2x is negative, the cosine for any angle for the second quadrant is always negative. Now for the b, sine of 2x, so for the sine they have only one formula, is 2 sine cosine. So the sine is given in the question, but the problem is the cosine. How can I find the cosine? I mean, the cosine is given, I have to find the sine. How can I find the sine? How can I find the sine and they give me the cosine? So now question 2 is find the sine of 2x is equal to sine of the half of the angle cosine of x. Cosine to square minus 1 is equal sine square. Yes, exactly, but in which one? This one, right? Cosine square minus 1. Yes, exactly. So he using the Pythagorean, right? So he using the Pythagorean identity. He said sine square of x is the same as 1 minus cosine square of x. So sine of x is equal to square root of 1 minus cosine square of x. So now I can find the value for x. This is given from the question. This is I can find from here, from the Pythagorean identity. So what is the sine of so sine of x equal 1 minus the value for the cosine is given in the question, minus 2 over 3. And this is equal 1 minus 4 over 9. And this is equal 1 minus 4. This is 9 over 5 over 9. and this is equal square root of 5 of square root of 9 is 3. So this is the value for x, for the sine. So the value for the sine is this. Now, for the sine of 2x, so sine of 2x equal 2 sine of x times cosine of x. 2 sine of x, this one, and the cosine of x is given 2 over 3. Minus 2 over 3. So what I get now? 2 times square root of, so it's equal minus 4 square root of 5 over 9. And this is the answer. Any question? So again, hold on, there's a mistake I made it. So for the cosine for 2x, so the angle, the value, it's the angle is in the second quadrant. The only positive is the sine function. But about the sine 2x, maybe positive, maybe negative. Why? Because I found it from here. They give me negative. So the sine only positive in the second quadrant. For the sine 2x, maybe positive, maybe negative. It's not depending on the sign. The same things for the cosine. So the cosine of x must be negative in the second quadrant, but the cosine of 2x may be positive, may be negative. It's not depending on the quadrant. Okay, so I'm going to stop up to here today, and next time I'm going to continue this section for 7.3. The quiz will start at 9:40, but I'm going to make it at 9:37. Okay? Any question before we end this class? Any questions? Okay, I'll see you next week.